Welcome to our YouTube channel Incredible Maths. In this video, we will solve problems asked in CSIR in February 2022. So related to complex analysis. So here we will solve two problems. So the first problem is this one. So gamma be the positive order circle z belongs to z such that mod is equal to 3 by 2. So given the integral over c e power I pi z divided by z minus 1 to z minus 2i square dz equal to 2 pi I into c. So here we need to find the value of modulus of c. So this problem can be solved using Cauchy's integral formula or Cauchy's residue theorem. So we will solve this problem using Cauchy's residue theorem. So for that we need to find the poles. So the poles are given by equating the denominator to be 0. So the denominator is z minus 1 into z minus 2i square equal to 0. So you will get z equal to 1 comma 2i. So this is a simple pole of order 1 and it's a multipole or double pole. Z equal to 2i. So this one, so this equal to, so 2 pi I, the formula is 2 pi I into sum of the residue. So here there are two poles. So first we need to classify whether these poles lies inside or outside. So for that, so we will consider the inequality mod z less than 3 by 2. So from this one, so if this inequality is satisfied, then the point the pole lies inside, otherwise it lies outside. So clearly 1 is less than 3 by 2. So this is satisfied, therefore this lies inside. So this lies inside. So next we will check for 2i. So modulus of 2i is less than 3 by 2. So we will check. So modulus of 2i is 2, that is root 4 is 2, is less than 3 by 2. So this is not satisfied. Therefore this point lies outside. So therefore, so this equal to 2 pi I into sum of the residue. So that is residue of f of z at z equal to 1. It is enough to find residue of f of z at z equal to 1 because z equal to 2i lies outside. Therefore, so this equal to 2 pi I into, so the formula is limit z tends to 1 z minus 1 to f of z. So f of z is e power I pi z divided by z minus 1 into z minus 2i square. So we can cancel this. So already given that, so this integral is equal to 2 pi I c. 2 pi I capital C. So this we can cancel 2 pi I. So therefore c can be found out by solving this. So when we substitute z equal to 1, so e power I pi, it will become e power I pi. So that is cos pi plus I sin pi divided by 1 minus 2i square. So this equal to, so cos pi is minus 1, sin pi is 0. So therefore minus 1 divided by 1 minus 2i square. So we need to find a modulus of c. So modulus of c is equal to modulus of minus 1 divided by 1 minus 2i square. So this equal to 1 by so modulus of 1 minus 2i square. So this equal to 1 by root of 1 square plus 2 square. So here we have square. So this equal to 1 by 5 root 5 square. So this equal to 1 by 5. So the answer is 1 by 5. Or we can expand this 1 minus 2y square. So you will get the same answer. So 1 by 5. So now we will solve the next problem. So it is question number 481. So if you like the content of these videos, so kindly like and share with your friends. Also support our channel. So let us see the problem. Let f of z be a non-constant entire function and z equal to x plus iy. Let u, v denotes its real and imaginary parts respectively. Which of the following statement is false? So this question is a simple question. So we can directly write the answer. So here we need to be careful. So here we have to find the false statement. So given that f of z is a non-constant entire function, so therefore, so entire function it will be analytic function. So analytic function means it will satisfy CR equations. So CR equations are given by ux equal to vy and uy equal to minus vx. So therefore, so the first option is correct. Ux equal to vy and uy equal to minus vx. So this is CR equation. And the second option uy equal to vx. So this is false. So this is not true. And since f is entire function, so it will be differentiable. So therefore, so what is f of z is equal to u plus iv. So when we differentiate with this with respect to x, so we get f dash of s equal to ux plus I times vx. And modulus of this one, so a modulus of f of z is equal to ux square plus vx square. Ux square plus vx square. So this is root of, and the modulus of f dash of z square is ux square plus vx square. So the third option is true. Option C is true. And similarly, when we differentiate f with respect to y, we will get uy plus vy. So this will also be correct. So the false statement is option B. So this is a correct option. So the option for this question is option B. So here we need to find the false statement. So this is the only false statement. So the other statements A, C and D are true statements. Okay, thank you.